Okay. Okay. Good afternoon, dear students. I hope you, yes, I hope you have gone through the synopsis of solutions chapter. Okay. So we are going to start. So I have taken some of the important questions. Okay. So what type of questions are asked from this particular chapter solution? So I have taken those questions. So we'll start. Okay. 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 So this is the first question. Which of the following can be measured by the Oswald-Walker dynamic method? Okay. So which of the following can be measured by the Ostwald-Walker dynamic method? Options are A, vapor pressure of the solvent, B, relative lowering pressure or vapor pressure, C, lowering of vapor pressure, and D, all of this. So this was a question asked in 2008 paper. Okay. So what is this Oswald-Walker dynamic method? Okay. As you know, we have okay, so you might have gone through the concept called colligative properties, right? In colligative properties, so there are four important properties, okay, in what we are going to study in colligative properties, that is elevation in boiling point, relative lowering of vapor pressure, osmotic pressure, right? Freezing point, so depression in freezing point. So these are the four main colligative properties. So colligative property, it depends on what? It depends upon the number of solute particles, right? So here, Oswald-Walker dynamic method. Okay, so among these four, the answer is B, relative lowering of vapor pressure, which is one of the colligative property. Okay, and so Oswald-Walker was a scientist. Okay, he put forth this dynamic method. Okay, for calculating the relative lowering of vapor pressure. So it is used for measurement, for measuring the relative lowering of vapor pressure. So, so this is a method which is used for measuring the relative lowering of vapor pressure. So if you see the options also, okay. So when we are talking about colligative properties, main four colligative properties: relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. Okay. But here, if you see the options, vapor pressure of solvent. So this is not any colligative property. Lowering of vapor pressure. No, it is relative lowering of vapor pressure, right? So this option is also wrong. All of this, so this is also wrong. So our answer is option number D. I hope this, okay, fine. Let us go for the next one. Vapor pressure of pure A. Okay, there are two liquids, pure liquid A and pure liquid B. So vapor pressure of pure A is 70 mm of Hg at 25 degrees Celsius. It forms an ideal solution with B, in which mole fraction of A is 0.8. If the vapor pressure of the solution is 84 mm of Hg at 25 degrees Celsius, the vapor pressure of pure B at 25 degrees Celsius is. Okay. So this is our question. So we will understand the question. I'll read out the options first. A, 56 mm, B, 70 mm, C, 140 mm, and D, 28 mm. So this was a question asked in 2009 paper. Okay. Now here, what all is given? So first, what important thing you have to do is, you have to, what all things are given, that you have to note down. Okay. Now, what all are given here? Now here, the pure liquid, okay, pure vapor pressure of pure liquid A is given. So how do we denote vapor pressure of pure liquid A? P naught of A. Okay, P naught of A, that is 70 mm. Okay, that is 70 mm. Then what is given? It forms an ideal solution with B, in which the mole fraction of A is. So mole fraction is given. Okay, mole fraction is given, which is given by, okay, psi A, that is 0.8. So this is the mole fraction given. Now, if the vapor pressure of the solution is 84 mm of Hg. So this is what? This is the total vapor pressure, which is 84 mm. Okay. Then the vapor pressure of B at 25 degrees Celsius is. So they have asked to find out what? We have to find the vapor pressure of pure liquid B. Okay. Now here we have mole fraction of A. So what is mole fraction? What is mole fraction? It is the number of moles divided by total. Yes, very good. Okay, so mole fraction. So when we are calculating mole fraction, okay, so how we are going to calculate mole fraction? Okay, so if you are calculating the mole fraction of A, it is number of moles of component A into total number of components A plus B. Okay, so this is about the mole fraction. So here, this is, okay, now here, and we know that the total, now if you want to calculate the mole fraction of B, it is number of moles of B upon the total moles of A and B, like this. Okay. Now we know that the sum of the mole fraction, that is XA plus XB is equals psi A plus psi B is equals to 1. So from this, can we calculate B psi B? Yes. Right. So how can we calculate? So it is psi 0 point this plus psi of B is equals to 1. So psi of B is equals to 1 minus 0 0.8, which is 0 0.2. So this is our, we got the mole fraction of B also. Okay. So now we have to apply. Now we have got psi A, psi B. Okay. Now we have to apply the Raoult's law. So according to Raoult's law, the vapor pressure, total vapor pressure is equals to the this what? Pure vapor pressure into the mole fraction of A plus pure vapor pressure of B into mole fraction of B. Okay, so this is a formula which we are applying. Now let us substitute. So we have the total vapor pressure given. So what is the total vapor pressure? It is 84. Okay, then P is given 70 into psi is 0.8 plus. Then this we don't know. We have to find out into psi of B is 0.2. Okay. Can you calculate? Simple calculation now. Yes. Just see what answer you're getting. So if you have simple calculator, you can use. You can carry a simple calculator, not scientific calculator. Simple calculator for doing this simple calculations. Yes, did you get? So do 84 minus 56, you get 28. Okay, then it is your, it is multiplying, you have to do your divide. Okay, so it is 0.2. So 28 divided by 0.2. So 28 divided by 0.2 is
140.
140 mm. Okay, so it is option number C. So if you have a small simple calculator, you can use. Okay, for your board exam as well as for your CT exam, small simple calculators are allowed. Okay, fine. So let us proceed. I hope this is clear. Okay, so what we have done here, so two liquids are there, pure A and pure B. Okay, in pure A, the vapor pressure is given. Then mole fraction of pure A is given, and total vapor pressure of the solution is given. Okay, and they have asked us to find out the vapor pressure of pure B. Now, from this data, okay, this is a given data. From this data, a mole fraction, okay, we know that mole fraction of A plus B is equals to 1. So by this data, we can, what we can do, we can substitute and get the mole fraction of B, that is 0.2. Now, according to Rawls law, okay, after using the Rawls law, total vapor pressure is equals to sum of the vapor pressure of pure component A into its mole fraction A plus vapor pressure of pure component B into mole fraction of B. So applying this, put the values what are given, substitute them and get the vapor pressure of pure component B, that is 140 mm. Okay. So like this only questions will come, only change in the numbers. Okay. So similar type of questions will be there. So this is on basis of Raoult's law. Okay. This is on basis of Raoult's law. Let us go for the next one. A 6% solution of urea is isotonic with A 0.05 molar solution of glucose, B 6% solution of glucose, C 25% solution of glucose, D 1 molar solution of glucose. Now, what do you mean by isotonic solution? What do you mean by isotonic solution? Solution having same osmotic pressure, right? Yes. So solutions having same osmotic pressure, or you can say same concentration. Okay, it is called as isotonic solution. Now they have asked a 6% solution of urea. Okay, 6% solution of urea is isotonic with which of the following? So these are the 4 options given. Okay, now what is isotonic? We have just seen. Okay, so now when a solution of urea, that is 6%, is isotonic with the which of the glucose solution? There are 4 different concentration of glucose solution given. So we represent the osmotic pressure as pi. Okay, so pi is equal to CRT, right? So this is the your osmotic pressure, that is pi is equals to CRT, where C is the concentration of the solution, R is the universal gas constant, and T is the temperature. Now here R and T are constant. Okay, so we are only considering what? Pi is equals to C. So pi is equals to C. So pi of glucose, okay, is equals to concentration of glucose, which is equal to isotonic means that is of urea is equals to concentration of urea. Right, right. Now, what is concentration? Concentration is what? How do you calculate concentration? Concentration of any solution? By how we are calculating? By number of moles, right? So number of moles, concentration of any solution. How do we express concentration in terms of molality, right? How do you calculate molarity? Number of moles upon given volume of solution in 1000 ml, right? So concentration is number of moles. Okay, number of moles into given volume in given volume, okay, of solution in 1000 ml. Okay, or you can write only given volume of that is volume of solution, number of moles upon volume of solution. Now how to this? Okay, now we'll put, so that is given weight. It is expressed how? Given weight is number of moles. Now how to calculate number of moles?
Given
Number
the molecular mass.
Yes, very good. Given given weight upon the molecular weight. Okay, so this all things you have to remember. So concentration is calculated at number of moles upon volume of solution, and number of moles is given weight upon molecular weight. Now let us put the here. Okay, so this can be yes, urea, which is equals to C of glucose. We can write like this also, right? See, concentration of glucose, which is equal to concentration of urea. Okay. Now, therefore, so let us put concentration terms. So given weight is expressed in small w, okay, upon the molecular weight, okay, molecular weight, then into 1000 and multiplied by 100, right? So given weight upon molecular weight, so that is divided by 1000 and this. So it will be, which is equals to same of urea. This is for glucose. Let us write for urea into 1000 divided by molecular weight of urea into 100. Okay. So here, what is small w? It is the mass of the glucose. Capital, this is molecular mass of glucose. Then mass of, this is mass of urea. And this is molecular mass of urea. So let us put the values now. Let us put the values. So what is the mass of the this glucose? We don't know. So let us keep it as X. Okay, that we have to find out. Into 1000. Then what is the molecular weight of glucose? C6H12O6. Okay, it will be 180. It will be 180 if you do this. Okay, that is 12 into 6 plus 12 into 1 plus uh, 16 into 6. Okay, like this. So into 100 is equals to, then what is the given mass of urea? Given mass of urea is 6%. 6% is nothing but 6 by 100. Okay, so it is 6. So 6 into 1000, then the urea, okay, urea is 60. Urea is 60. So that is 60 into 100. So this is 1000, okay, up, and this is 100. Okay, now you do simple calculation. This is urea if you want to calculate, okay, NH2, C double bond to NH2. So this will be, if you calculate, nitrogen as 14 plus 14 plus 4 4 hydrogens plus 16 plus carbon. Okay. Calculate, it will come to be 60. You have to find the value of X. You have to find the value of X.
One more solution for me.
Yes. How much?
Go
It will
ahead.
be, cancel everything, no? It will be X is 18 grams. Okay. 18 grams. So 18 grams of glucose, if it is present in 100 ml of solution, okay, 18 grams of glucose, 180 is nothing but what? 180,
Molecular mass of glucose.
yes, it is the glucose. So if 18 grams of glucose is present in, so 180 in 1000 ml, right? That is equals to 1 molar. So 18 grams in 100 ml is what? It is also 1 molar, right? It is 1 molar. So 1 molar of glucose is isotonic with 6% of urea. So it is option number D. Option number D. So 180 grams, if you are dissolving in 100 ml, okay, 180 gram in 1000 ml, sorry. So it is 1 molar. So your 6%, okay, 6% of urea is what? 6% of urea means 6 by 100. Now here 18 grams. So 18 grams also we have taken with respect to 100 ml. So 18 grams in 100 ml is also 1 molar. Okay. So option number D. So our 6% solution of urea, it is isotonic with 1 normal solution of glucose. Is it clear? Okay. So these things you have to remember. Concentration, how to calculate concentration. See how only one isotonic they have given. These all things are not mentioned, but you have to use these all things. Concentration comes in. Concentration will come, then number of moles. Okay, then you need to know the molecular mass of urea, how to calculate the molecular mass of your glucose. So these all things you have to. Okay, let us go for the next one. Okay, in countries nearer, so this is a theory-based question. In countries nearer to polar region, the roads are sprinkled with calcium chloride. Okay, this is A, to minimize the snowfall, B, to minimize pollution, C, to minimize the accumulation of dust on the road, D, to minimize the wear and tear of the roads. So, what is this calcium chloride? So
Salt.
calcium chloride, it is a, yes, it is a type of salt. Okay. So it is a non-volatile solute. Okay. Solute is what? Solute is which is present in the small amount, right? Small quantity. So it is a non-volatile solute. Okay. So when you use this non-volatile solute, it results into depression in freezing point. Okay. Yeah, it results into depression in freezing point. It is responsible for the, so whatever the snowfall, so in the polar region, okay, the snowfall will be more in that area, right? So by what is happening here, so if you sprinkle this calcium chloride, there will be the freezing point will be depressed. Okay, it will, the depression of freezing point takes place. So because of that, what will happen, the snowfall will be reduced and it will prevent the blocking of road. So on the road continuously snow will fall, right? So because of that, the road will get blocked. So what the people they do there, they sprinkle it with calcium chloride so that it there will be minimization in the snowfall on the roads. Okay, so option number A. So remember this. So calcium chloride is what? It is a non-volatile solute. It helps in what? It helps in depression in freezing point. Okay, so because of that, the snowfall is reduced, which helps to prevent the blocking of roads. Okay. Let us go for the next one. The empirical formula of a non-electrolyte is CH2O. A solution containing 6 grams of compound exerts the same osmotic pressure as that of 0.05 molar glucose solution at the same temperature. The molecular formula of the compound is. Now, another different type of question. Okay, so here also osmotic pressure. So a solution containing 6 gram of compound exerts the same osmotic pressure as that of 0.1 0.5 molar glucose solution at same temperature. Okay, so they have given the empirical formula of a non-electrolyte is CH2O. So here again isotonic. Okay, here again we are making use of isotonic. So your isotonic solution. Okay, so isotonic solution is what? So here, what all things are to be mentioned? So your non-electrolyte, this is empirical formula is given, which is H2O. Then a solution containing 6 gram of compound. Okay, 6 gram of compound is there. So that is mass of a compound. So I'll take it as W2. Okay, I'll take it as W2. So, and one more is glucose. So let us take glucose as W1. So glucose is W1, which is the mass of the glucose, which is 0.05. So 0.05. How to calculate the mass? Okay. So they have given molarity, not mass. It is 0.05 molarity is given, right? So we have to calculate the mass. So how to calculate mass? We can calculate molarity into its molecular mass. Okay, so what is the molecular mass of glucose is 180. Okay, is 180. So calculate 0.05 into 180. 0.05 into 180. So it is 9 grams. Okay, so the weight of the glucose. So this is the mass of the glucose. I'll write it here. Okay, mass of the glucose is W1, which is 9 grams. Then Molecular mass, we know it is 180. Okay, 180. Then what we want? W2. W2, it is 6 grams. W2 is 6 gram. We don't know which is that compound, right? So we don't know the molecular mass. W2, M2 also. Now, volume. Volume will be what? It is a standard solution. Okay, molar. So it will be V1 and V2 we will consider it as 1000 ml. That is 1 liter. Okay. Now, let us put the formula. So that is W1 into M1 into V1 is equals to W2 into M2 into V2. So put the values. W1 is what? W1 is
9 grams.
9 grams. Okay. Then this is 180 into 1000 is equals to 6 into M2 is, we don't know, into 1000. So this is both 1000. Okay, this will get cancelled. So it will be 9 by 180 is equals to 6 by M2. So just cross multiply. How much it will be? Just see, M2 into 9 is equals to 6 into 180. Okay, M2 is equals to 6 into 180 divided by 9. 6 into 180 divided by 9. 6 into 180 divided by 9. 120. Yes, M2 is equals to 120 grams. Now, okay. So first year you have studied how to find the N, right? Molecular mass upon the empirical mass. So we have molecular mass, we have the empirical mass. Empirical mass, how to calculate? This is the formula CH2O, right? So let us put the values. Okay, so here, so it is molecular, therefore, molecular mass upon empirical mass. Okay, it will give you N. So how to calculate N is a molecular mass upon empirical mass. We have to calculate the molecular formula, no? So now N is equals to molecular mass is what? 120 and empirical mass CH2O. 16 plus 12 plus 2.
32.
30, right? 30 and 10, 30, yes, 30. So it will be 4. It is 4. N is equals to 4. Now, therefore, molecular formula. How to calculate molecular formula? You have to multiply N into the empirical formula, right? Empirical formula. That is, N is 4. Empirical formula is CH2O. So C4H, O to the 8 and O4. So it is C4H8O4. Right? C4H8O4. Option number B. Right? So what we have done? So here two compounds are given. One compound, okay. They have given its what molarity. Okay, we have found out the mass of the glucose. We know the molecular mass. Okay, volume is constant 1000 ml because it is a concentrated solution. Okay, then we don't know which is the other solvent. Okay, which is the other compound. So then what we have done? So the given mass is given. Then we don't know its molecular mass. Okay, from that we have found out the molecular mass. Okay, because these two solutions are isotonic. So by using that formula, we have found out the molecular mass. Then we know how to calculate the find out the molecular formula. Okay, that is molecular mass upon empirical mass. We get the number. Okay, N. That N we have to multiply with the empirical formula and we will get the molecular formula. So N is what? 4. So 4 into CH2O. So it is C4H8O4. So option number D is the answer. Okay. So similar, one more question is there. you have to solve this.
Not even any osmotic, like isotonic means they are mentioning like the same osmotic pressure. If they are not mentioning, so how we have to do?
I did not hear. Come closer.
They are in the question they are saying the same osmotic pressure, right? In case they
Ha.
are said that like same osmotic pressure means, so we can't use the isotonic. In that case,
No,
what?
no. No, these are the question based on isotonic. No, because they have mentioned same osmotic pressure. So same osmotic pressure means we have to use this formula. That is isotonic formula. Okay. Other formula.
We have to
So
use
these.
isotonic base, like
Can you come closer? That voice is echoing.
in this type of questions, we have to just take only isotonic case.
Ha.
Yeah.
Yes. Isotonic because see after reading the question. Now, how we came to know it is isotonic?
Same.
Because they have said same osmotic pressure. Same osmotic pressure means we have to use the formula of isotonic. Now we know how to use isotonic. Isotonic because pi is equals to CRT. R and T is what? It is constant. So only concentration will change, right? With respect to the osmotic pressure. So osmotic pressure of this is equal to C. So we know how to find again concentration. We know how to calculate number of moles. So that by that we know one formula. So that formula we have to apply. Then after getting that formula, we have to find out what the unknown thing is. Now your unknown thing was the molecular formula weight, right? Because two compounds are given. One compound we have found out the mass. We know the because we know the compound, we know its molecular mass, and the another which is unknown compound they have given the mass, but we don't know the compound, so we don't know how to write the molecular formula. So by using the isotonic formula, we have found out the molecular weight. Okay, after that, again, this basic is from first year, right? How to find the empirical formula for molecular formula. So that we have joined there and we have found the molecular formula. Okay. So by using that word only, same osmotic pressure, we came to know that this problem is of isotonic. So that we can apply. Okay. Okay. So same question you can copy down. Okay. Same question. Only see how they have changed. Here they have given 6 grams of compound. Here they have given 3 grams of compound. Okay. So just you can solve this. Same. The empirical formula of a non-electrolyte is CH2O. A solution containing 3 grams of the compound exerts the same osmotic pressure as that of 0.05 molar glucose solution. What is the molecular formula of the compound? So like this, they will change the numbers. Okay, the type of question, if you see the papers also, previous year's questions, repeatedly asked questions, okay. So the type of question will be same, only numbers will be different, or they may little twist the question.
Yes, sir.
The answer you should get is B. Okay. So just note down the option. It is B, but please solve it. You will understand. Okay. Did you copy? We'll go for the next one.
Yeah.
Okay. A solution of a theory question. A solution of two liquids boils at a temperature more than the boiling point of either of them. Hence, the binary solution shows A. Negative deviation from Raoult's law. B. Positive deviation from Raoult's law. C. No deviation from Raoult's law. D. Positive or negative deviation from Raoult's law, depending upon the composition. So a solution of two liquids when they are boiling at a temperature more than the boiling of either of them. Okay, then what is the binary solution showing? Negative, positive, no deviation, or positive or negative depending upon the composition.
Intermolecular ಜಾಸ್ತಿ ಜಾಸ್ತಿ ತಗೊಳ್ತಾರೆ negative.
It is means what? Higher. It is at a higher temperature. Okay, remember that. It is at a higher temperature of either of two. Binary solutions means what? The two liquids. Okay, two solutions when they are mixed, right? So you get a binary solution. Binary means two. Now here the boiling point of that solution is higher. The two liquids are boiling at a higher temperature than whatever the boiling point is there of that two liquids. So your higher temperature. So the solutions are boiling at a relatively higher temperature. Your vapor pressure of the solution will be what? Vapor pressure of the solution will be less. Okay, it will be less. So because of that, it will show negative deviation from Raoult's law. So option number A, because the vapor pressure, because it is boiling at a higher temperature, okay, then the other two solutions. So because of that, the vapor pressure of the solution will be less. So negative deviation, option number A, negative deviation from the Raoult's law. So this is a theory based question. Okay. Next question. The mass of non-volatile solute of molar mass 40 grams per mole that should be dissolved in 114 grams of octane to lower its vapor pressure by 20% is A, 10 grams, B, 11.4 grams, C, 9.8 grams, D, 12.8 grams. Okay, so this was a question asked in 2012. So here, okay, now Raoult's law. So this is a question based on Raoult's law. Now, according to Raoult's law, so we have a formula. So the mass of a non-volatile solute of a molar mass 40 grams per mole. Okay, so here this is given. Then it should be dissolved in 114 grams of octane to lower its vapor pressure by 20% is. Now, according to Raoult's law, the formula is P naught minus P of S upon P naught. So this formula we are going to use. So weight of A upon the molecular weight of A divided by molecular weight of A plus this by NV. Okay. Now here, what is this W? A and MA? This is the weight dissolved. Okay, weight of the given weight upon the molecular mass of the solute. So this is of the mass of solute and molecular mass of solute. Now WB and MB. Okay, what is this? This is again mass of solvent upon the molecular mass of solvent. Then what is P naught? P naught is vapor pressure of pure solvent. Okay, this is the vapor pressure of pure solvent. What is PS? It is the vapor pressure of solution. Vapor pressure of solution. Now, by using this formula, okay, now what all is given here? Vapor pressure is given, right? Vapor pressure is given, that is 20%. So vapor pressure of pure solvent is given, that is 20%. Vapor pressure of pure solvent given is 20%. 20% means 20 by 100, which is 0.2. Right. Now, again, what is given here?
Your state also given then.
Molecular weight is given. Molecular weight of solute is given. Non-volatile, right? 40 grams. So molecular weight of solute is 40 grams. Then what is given? This is given. That should be dissolved in 114 grams of octane to lower its vapor pressure. 114. This is what your this is given. What is that? WB. Okay, that should be dissolved in 114 of octane. That is solvent, right? So this is of solvent. Weight of the solvent is 114. Octane. Octane. Find out the molecular weight of octane. Octane.
C8 extra, no? C6. C8 extra.
C8H 18. C8H18.
6 plus 8.
12 into 8 plus 18. 100
14. 114.
96. 96
114.
plus 18. 96 plus 18. 18, no? 114. Okay, this is also 114. So our molecular weight is also 114 grams. Okay, now let us put this values. Let us put this values in the formula. Let us put the formula. Okay, so P naught. P naught is what? P naught is 0.2. P naught minus this P naught minus PS by this is your vapor pressure is given, okay, of the solution. So this total will be P, 0.2 is equals to WA, we don't know. Then molecular mass is 40 divided by, then WA we don't know, by 40 plus 114 by 114. Now that is equals to WA by 40 into, so this we can take 1, right? So this becomes 1. So it is equal to WA plus 40 divided by 40 because this is 1. Okay. So now next step, 0.2 is equals to, so WA get cancels this 40 and this becomes WA by WA plus 40. So this 40 cancels, right? So WA plus 40. So do cross multiplication now. Next step, I'll do it here. So 0.2 is equals to, so this becomes WA
0.2
plus
W plus 40 is equal to WA.
0.2 into 40
is equal to W.
is 8. Okay, plus 8 is equals to WA.
3.9.
Then 8 is equals to WA minus 0.2 WA.
8
So that is
divided
equal to 0.8 into WA. How much you have got?
0.2.
Just see. Just W into WA. Okay, multiplied. So this W into this into 8. So this will be, I am getting it as 10 grams. Just see.
Yeah. Is it 8 divided by 0.8 we have to do now?
Yes, 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 yes. Everybody got 10?
Hmm.
So your calculation only you have to see. Okay, substitution you have done properly. In calculation, if you do any mistake, then it will be.
Yes, you can come. Ma'am, is it for every subject or only for the chemistry the calci sub? Like small one?
For in your this for boards it is allowed or no for you all?
Yeah,
In
both it's a lot, but what about CET exam?
CET I'll confirm again. Okay, this year's I'll just confirm.
Yeah.
Okay. Is it? Did you get 10?
Yeah, yes, ma'am.
Okay, fine. So like this. Okay. So You have to find out. Fine. So option number A, right? Yeah. Option number A is 10 grams. Okay. So this is the answer. I hope you have noted down.
Yes, ma'am.
Okay. Let us go for the next one. Okay. The vapor pressures of two liquids A and B in their pure state are in the ratio 1:2. A binary solution of A and B contains A and B in the mole proportion of 1:2. The mole fraction of A in the vapor phase of the solution will be. Now, what all things are given here? So, what they have given first is the vapor pressure of pure liquid A and B is in the ratio of what? 1:2. So, this is given. Okay, so this is given here. Two liquids A and B are in the ratio of. Now, a binary solution A and B again are in the mole proportion of. So, this is mole proportion. So, mole proportion. So, here what from this, what you will come to know, a mole proportion is nothing but your, if you are finding out of A, it is Na upon Na plus Nb. Okay, and the mole proportion of B, Nb upon Na plus Nb. This is psi of A and psi of B. Now, from this, okay, so what they want, the mole fraction of A in the vapor pressure of the solution will be. So, from this data, so PB is equals to what? It will be 2 times vapor pressure of A. Okay. Now, if we find out the mole fraction, if we find out the mole fraction of A in vapor pressure, it will be what? Vapor pressure of A upon vapor pressure of A plus B. Now, put the values. This substitute B is equals to 2 times PA. So, PA is equals to vapor pressure of PA plus 2 times PA. Okay. Now, what is PA? What is the value of PA is 1. Okay. Now, and what is the PA? 1. This, right? And what is 2 times PA? 2 times 1. Right. So, what it is? 1 by 3. 1 by 3. What is the value of 1 by 3?
0.33.
0.33. So, which is the answer?
A.
A. Okay. So, like this. So, the vapor pressure of two liquids A and B, they have given. So, from that data, we got to know that PA is equals to 2 times PA, mole fraction of A in vapor pressure. So, vapor pressure of A upon vapor pressure of A plus B. So, after substituting the value of PA, PB, that is equals to 2 times PA, put the values. Okay, PA is 1, PB is 2, but okay, then PA is 1, PA is 1 plus 2 into PA, that is 1. So it is 1 by 3, that is 0.33. So option number A is the answer. So this was a question asked in 2012. Okay. Next question. Which of the following is not a colligative property? Which of the following is not a colligative property? A, elevation in boiling point. B, depression in freezing point. C, osmotic pressure. And D, lowering of vapor pressure.
D.
D, right? It is elevation in boiling point is a colligative property. Depression in freezing point is a colligative property. Osmotic pressure is also a colligative property. Lowering of vapor pressure is not a colligative property. It is relative lowering. Okay, the word should be relative. So this is wrong. Yes, option number D. Okay, which is not a colligative property is option number D. Very good. So this was a question asked in 2013. Next question. 3 grams of urea is dissolved in 25 grams of water. The relative lowering in vapor pressure is. How you are going to solve this now? The relative lowering of vapor pressure, this formula by P naught is equals to the relative lowering in vapor pressure is 3 grams of urea is dissolved in 45 grams of water. Okay, so water is the solvent and this is the solute. Now, the relative lowering of vapor pressure, it is given by this formula. Okay, now here now this is a very dilute solution. So for any dilute solution, N2 can be neglected. Okay, remember that for a dilute solution, this is a dilute solution. For dilute solution, N2 can be neglected. Okay, if N2 is neglected, then it will be P naught minus PS, that is vapor pressure of solution, by P naught is equals to N2 by N1. So this is neglected. So put the number of moles of this, okay, number of moles N2 by N1. So N2 is what? It is the solute. Okay, so 3 grams given weight upon the molecular weight. How to calculate number of moles? Number of moles is given weight upon molecular weight. So 3 by what is the molecular weight of urea? 60. Okay, and N1 is what? N1 is of water. Given weight of water is what? Water is 45 grams and molecular weight of water is 18. Okay, is 18. Find out 3 by 60, 45 by 18. No, for your KCET calculators are not allowed. Okay, for board exams it is allowed. Hmm.
One by 75.
3 by 60.
0.001 is coming.
0 0.00.
No, ma'am, only 0.01.
Hmm. No, I've got 0.02.
Again, wait.
Okay, you have to get 0.02 mm. Option C. Three by 60, you will get 0.05. Okay, 3 by 60. And 45 by 18, you get 2.5. Then 0.3 by 60 into 18 by 45. 3 ones are 3 ones are. So first you simplify and then you multiply.
1 by 50 is coming after 75.
15.
Yeah, ma'am, 0.02.
0.02, okay. So 9 by 15. 1 by 50. Right?
Yeah.
Like this you do. Simple, okay. So like this simple way you have to just go and cancelling. Then you'll get a simple number. Then you can understand what the answer will be. So 1 divided by 50. It will be 0.02. Yes. Okay. Option number C. Okay. Which of the following aqueous solutions will exhibit highest boiling point. A 0.01 molar urea, B 0.01 molar potassium nitrate, C 0.01 molar Na2SO4, and D 0.015 molar glucose. Okay. So which of the following will exhibit highest boiling point? Now here for this elevation in boiling point formula is there, delta T is equals to I into Kb into M. Okay, so this formula you have to use. Delta T is equals to I into Kb into M. Okay, now here what you have to calculate, Kb is constant. Okay, now here your this, what is that? I into M. So the value of I into M will play the role. Okay, so whoever's I into M value is more, its boiling point will be also more. Okay, now if you calculate the number of ions, okay, now here the number of ions of urea, it is a non-electrolyte, so it will be 1. So you have to calculate I is equals to 1 here, right? So I, then for KNO3, K plus NO3 minus, right? So K plus is 1, this is 1, so it will be 2. So this is 2 this. Then Na2SO4. So this is Na2 plus, okay, 2Na plus SO4 minus, okay, SO4 minus 2. So this is 2 plus 1. It is 3 ions. Then C6H12O6, this is again non-electrolyte. This is considered as 1. So this is 1, this is 2, and this is 3. Now, the concentration is same, 0.01, 0.01, 0.01, and 0.015. So molarity is same. So just multiply for each and see. So this is what I is equals to, so delta T is equals to, so here I into M, 0.01 into 1. Then for second one, 0.01 into 2. Next one, 0.01 into 3. 0.015 into 1. So just see whose value will be highest. Whose this is highest? I. Number of ions is of C, right? Na2SO4. So that only should come highest. 0.01 into 3 will be 0.03. This is 0.02. This is 0.01. This is 0.015. So which is highest? 0.03. Okay, option number C. So option number C. So whoever's I into M value, okay, is highest, its boiling point also is highest. So option number C. So number of ions I you should calculate properly. Okay. Understood?
Yes, ma'am.
Okay. Okay. Last question, we'll do one. 5.5 milligrams of nitrogen gas dissolves in 180 grams of water at 273 Kelvin and 1 atmospheric pressure due to nitrogen gas. The mole fraction of nitrogen in 180 grams of water at 5 atmospheric nitrogen pressure is approximately. Okay. So this is based on Henry's law, that is solubility of gas is directly proportional to what? Mole fraction. So this is based on the Henry's law. So number of moles of N2. So here what is given? 5.5 milligrams of nitrogen gas is dissolved in what? 180 grams of water. Okay. The mole fraction of nitrogen is 180 grams of water at 5 atmospheric pressure. Nitrogen pressure is the mole fraction of nitrogen in 180 grams of water at 5 atmospheric at nitrogen pressure is approximately. So they have asked you to find out the mole fraction. So number of moles of this is given as given weight upon molecular weight. What is the given weight of, so number of moles we'll find out first. Okay, number of moles is 5.5 upon N2. N2 is what? 14 plus 14. So it will be 28.
5.5 into 10 to the power of minus 3 will not come.
Yes. Milligram. No, yes. We have to take 10 raised to minus 3. Very good. Okay, so your solubility of gas is directly proportional to mole fraction. So first we have to find the for mole fraction number of moles is required. So first we are finding out number of moles. So milligrams is given. So you have to take 10 raised to minus 3. So 5.5 into 10 raised to minus 3 divided by 28. So number of moles, how much it will be? So 5.5 divided by 28. Okay, so 5.5 divided by 28. So you should get here 1.96 into 10 raised to minus 4. Okay, at 1 atmospheric pressure. So this is the number of moles you have to get.
Ma'am, KS value?
No, now you calculate number of moles. First we are calculating number of moles. Okay.
Yeah. So 1.9. Ma'am, after that?
Now here after this, okay. So now we know that pressure is also directly proportional to mole fraction. So first we have found out, so 5.5 milligrams of nitrogen gas is dissolving in 180 grams of water at 253 Kelvin and 1 atmospheric pressure due to nitrogen gas. The mole fraction of nitrogen in 180 grams of water at 5 atm nitrogen pressure is approximately. So now pressure is also directly proportional to mole fraction. So at 5 atmospheric pressure, if you are increasing the pressure by 5, this is at 1 atmospheric pressure. So if you increase the pressure at 5 atmospheric pressure, then mole fraction also will increase by 5 times, right? This also will increase by 5 times. So 5 into this your what is that mole number of moles, that is 1.96 into 10 raised to minus 4. So you have to multiply the number of moles of nitrogen into 5 times. So this how much it will be? 5 into 1.96 into 10 raised to minus 4. This will come approx 9.8 into 10 raised to minus 4. Okay. That is if you so this is 9.8 is nothing but approximately 10 into 10 raised to minus 4. So if I shift one more decimal, it will be 1 into 10 raised to minus 3. So it is option number 6. C. C. Option number C. So for 1 atmosphere pressure we have found out. Then they said that the mole fraction of nitrogen, okay, it was 5 times increase. So vapor pressure, if it is increased by 5 atmospheric pressure, mole fraction also will increase by 5 times. So we are multiplied this by 5 times. Okay. Is it clear?
Yes, ma'am.
Okay, fine. So remaining questions, okay, we will see in the next class. Fine.
Okay, ma'am.
Okay, fine. Any difficulty, any doubts? So we have solved some 13 questions. Okay, so similar questions, if you find out, if you have any good book, okay, try to solve similar questions like this. Okay.
Ma'am, like Sankalp only given in that book only we can practice no models.
Yes, yes. Yes, yes, yes. You can solve from those. Okay.
Yeah.
Yes, fine. Okay. Fine, fine. Okay, then I'll end the session here. Okay. Thank you.
Thank you, ma'am.